In this video, we'll go over the reduction formulas for integrating powers of the basic trigonometric functions. Let's say if you were asked to find the integral of the 8th power of sine of x dx. One thing you could do is to use a half angle formula and get that the integral of the 8th power of sine of x dx is the same thing as the 4th power of sine squared of x dx, which is equal to the 4th power of 1/2 of 1 minus cosine of 2x dx, but then you'd have to multiply that out 4 times and then use the half angle formula again 3 times. It would be quite tedious. But there is another way. But before we get to the reduction formulas, let's discuss the integrals of the basic trigonometric functions. As we have seen before, the integral of cosine of x dx is sine of x plus c. The integral of sine of x is negative cosine of x plus c. The integral of tangent of x dx is equal to the negative of the natural log of the absolute value of cosine of x plus c, which is the same as the natural log of the absolute value of secant of x plus c. The integral of cotangent of x dx is equal to the natural log of the absolute value of sine of x plus c. The integral of secant of x dx is equal to the natural log of the absolute value of secant of x plus tangent of x plus c. The integral of cosecant of x dx is the negative of the natural log of the absolute value of cosecant of x plus cotangent of x plus c. Now for the integrals of tangent of x and cotangent of x, we will write the function in terms of sine of x and cosine of x and do a basic u substitution. For the integrals of secant of x and cosecant of x, we will multiply the numerator and denominator by an appropriate sum of terms so that we can also do a u substitution. But now, what about the powers of the trigonometric functions? Here are the reduction formulas for when you deal with the powers of the trigonometric functions. The integral of the nth power of sine of x dx is equal to n minus 1, the n minus 1 power of sine of x times cosine of x, all divided by n, plus n minus 1 over n times the integral of the n minus second power of sine of x dx. The integral of the nth power of cosine of x dx is equal to n minus 1 power of cosine of x times sine of x, all divided by n plus n minus 1 over n times the integral of n minus second power of cosine of x dx. Now for the odd powers of sine of x and cosine of x, I would really only use for the powers of sine of x and cosine of x, I would really only use these reduction formulas for even powers. For the odd powers, I would use the Pythagorean identity and a simple u substitution. Now the integral of the nth power of tangent of x dx is equal to n minus 1 power of tangent of x divided by n minus 1 plus the integral of the n minus 2 power of tangent of x dx for n not equal to 1. Last, the integral of the nth power of secant of x dx is equal to the n minus 2 power of secant of x times tangent of x divided by n minus 1 plus n minus 2 divided by n minus 1 times the integral of the n minus 2 power of secant of x dx for n not equal to 1. Now let's look at an example using the reduction formula. One thing to note, many times with integrals of trigonometric functions, there is often more than one way to evaluate the integral. For this example, you're to find the integral of the 4th power of tangent of x dx. Now using the reduction formula, we get the integral of the 4th power of tangent of x dx is equal to 1/3 the 3rd power of tangent of x minus the integral of the square of tangent of x dx. Now using the reduction formula again on the integral, we get that this is equal to 1/3 the third power of tangent of x minus the quantity 1 divided by 1 times tangent of x minus the integral of the 0 power of tangent of x dx. That is the same as 1/3 the third power of tangent of x minus the quantity tangent of x minus the integral of 1 dx. Finally, that is equal to 1/3 the third power of tangent of x minus tangent of x plus c.